So within our frames, we have a source and destination MAC address that's going to be listed. So what do these source and destination MAC addresses look like? Well, they're going to be represented in many different formats. There's no standardized formats for MAC addresses. But first of all, they're 48 bits long. 48 bits long, which equals 6 bytes in total. And that, as a result, that really breaks down into 12 hexadecimal characters. So our MAC addresses are represented in hexadecimal. And our examples here, they're all the same. Our 3 examples are the same, except they are represented in 3 different ways. One's with periods, one's with colons, and one's with dashes. It really depends on the operating system as to how the MAC addresses are going to be displayed. So don't panic when you're looking at a MAC address if it doesn't look like what you're used to seeing. Could be periods, could be colons, could be dashes. It might not even have anything. It might just be 12 hexadecimal characters altogether. But realize when you see those 12 hexadecimal characters together, you're dealing with a MAC address. So the MAC address is broken into 2 portions. We can see here that we have an OUI, or an organizational unique identifier, and a vendor assigned portion, really split right down the middle. 24 bits on each side for our total of 48 bits. So what is the OUI? The organizational unique identifier is handed out to the various organizations that are creating network interface cards. So for example, Cisco. Cisco says, hey, we're creating network interface cards. We need an OUI. So the industry gives them an OUI of 00000C. And you can see that right there. So that's their OUI. That's the first 24 bits in the MAC address. That's the OUI. So that uniquely associates the network interface card with Cisco. And if you look that up on Google, you'll see that that is associated with Cisco. So anytime you want to see the manufacturer of your network interface card, you can just type in the first 6 hexadecimal characters, 24 bits, into Google and say, who owns this OUI? And you're going to get a result. It's going to tell you who the manufacturer of that network interface card is, just by the OUI. And then the manufacturers are going to go ahead and assign themselves a vendor portion themselves. So how are they going to do that? Well, they have 2 to the power of 24 options here. And they come up with this portion here all by themselves. It's 2 to the power of 24. 16 million, isn't it? About that, give or take. So what does that mean? It means that there is the potential for 16 million unique MAC addresses with every single OUI. What is the likelihood that we could have duplicates in the world? There is the likelihood of duplicates. But does that become an issue? Here's what I want you to realize about MAC addresses. If I have a network interface card in my environment with a MAC address assigned to it, if there's another device inside the exact same local area network, so off the exact same router interface, then we have a problem if it has the exact same MAC address. So let me draw something for you here. We're going to put it right up here. So we're going to have a router here. And then off that router, I'm going to have a switch. And then off that switch, we're going to go ahead and put just some devices. I'm going to do the same thing over here. Okay. Now let's go ahead and draw some lines. So I'm going to connect all these devices up rather crudely, but that's okay. That's essentially what we end up with in this scenario. If 2 devices off of this router interface, 2 devices off of this router interface, to the left-hand side of that router interface, have the same MAC address, we have a conflict. You cannot have 2 devices in the same local area network with the exact same MAC address. It's not going to work. Because when we want to talk and communicate inside that local area network, we are going to send our frames to the destination MAC address of the device and source them from our own MAC address. We have to be unique. But if a device over here, let's say this device, has the same MAC address as this device, does that matter? No, not at all. Why? Because they're in different local area networks. MAC addresses are only utilized in Ethernet within your local area network. I'll never ever learn or know about or care about a MAC address of a device in another local area network. Not at all. That's why it's important to know the definition of a local area network. It's all those devices in the same portion of our network off of a given router interface. So we can have the same MAC addresses in our organization as long as those MAC addresses are separated by routers, and that's going to be perfectly fine. So within a broadcast domain, unique MAC addresses. But between broadcast domains, that's not going to matter because we don't share the MAC address information between broadcast domains. We don't do that. So it's important. So what are the odds of having duplicate MAC addresses in a local variant network? Very slim. If you ever end up with that, meaning you purchase two network interface cards and they have the exact same MAC address and they just happen to end up in the same local area network, you go out and buy yourself a lotto ticket. I'm serious. Go out and buy yourself a lotto ticket because you have a better chance of winning the lotto than you did of getting what? Two network interface cards with the same MAC address deployed in the exact same local area network. It's mind-blowing. Mind-blowing.